You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
It is so easy to take for granted the incredible things happening in the space ecosystem, in space technology, launch, human exploration, you name it. Just a few days ago, we noted that we've hit the milestone of 100 FAA-authorized space launches this year alone. Well, okay, so here's a little trivia pop quiz for you. 39 years today marked the very first launch of the 3rd space shuttle ever. The space shuttle... what? Do you know it without Googling it? I'll tell you the answer at the end of the news read today.
T-minus 20 seconds to LOS egress. Go for deploy. Roger, roll.
Today is August 30th, 2023. I'm Maria Varmazes, and this is T-minus. SpiderOak demonstrates its OrbitSecure on the ISS. SAIC wins a U.S. Space Force ground radar systems contract. India's lunar rover finds evidence of sulfur on the moon. And our guest today is Charles Rath, founder and CEO of data science company RS21. Stay with us for that. And on to today's Intel briefing. A neat proof of concept announced yesterday by space cybersecurity firm SpiderOak. In late July, the company says that they had a successful demonstration of its OrbitSecure encryption technology aboard the International Space Station, showing that secure operations traffic could be successfully sent and received between ground and on-orbit stations and back. Axiom Space provided the snow cone, which is not a tasty frozen treat in this case, but an Amazon Web Service-powered edge computing device for the demo. SpiderOak aims to bring its OrbitSecure software for securing space systems comms traffic end-to-end to commercial, civil, and military space, especially as space systems become more complex and interconnected. John Moberly, who is SpiderOak's Senior Vice President for Space, says the future of space is undeniably software-defined. Our successful demonstration shows that it's not just possible, but effective and secure to run containerized workloads in modern orchestrated environments with secure data channels from orbit to ground and vice versa. Science Applications International Corp., or SAIC, has been awarded a $574.5 million task order to help the U.S. Space Force update and maintain a global network of ground-based radar systems. According to the press release, Space Systems Command received 4 bids for the cost-plus incentive fee contract via a competitive acquisition and is obligating $43.8 million in fiscal year 2023 operations and maintenance funds on the award. SAIC will perform the sensor sustainment and modification work in Colorado and other undisclosed locations, with an estimated completion date of the contract set for March 2030. The U.S. Space Force uses ground-based radar infrastructure to identify and detect missile threats, monitor low Earth orbit, and track deep space objects. Northrop Grumman previously had the contract to maintain the systems. Space News is reporting that space logistics startup TransAstra has been awarded a NASA contract to manufacture a bag to capture orbital debris. The Phase 2 Small Business Innovation Research contract, or SBIR contract, is reportedly worth $850,000 US. TransAstra plans to build an inflatable capture bag and demonstrate on terra firma how the device would capture a non-cooperative object. This isn't the first prototype from the company, as previously TransAstra built a small capture bag with the NASA Innovative Advanced Concepts funding. The U.S. Space Force is working with South Korea to integrate their systems for tracking North Korean missile launches. The countries are also looking to build on cooperation with Japan as well. This is the U.S. Space Force's first official component set up overseas. A spokesperson for the Space Forces says the partnership sees space integration as key to better tracking North Korean threats and responding to a conflict. And it feels like the moon is always in the headlines at the moment. And who can blame the moon, right? It's awesome. Lunar operations are being worked on by national space agencies around the world. And today it's the turn of U.S. space agency NASA, who says it's preparing its astronauts for the first crewed landing on the moon since 1972. NASA says it's been using data from the Lunar Reconnaissance Rover, or LRO, which was launched in 2009. The rover collected a lot of scientific data in its 14 years of operation. And NASA says it's been training astronauts on how to identify landmarks, spot geological features, and help mark areas of interest for future landings, all using the data gathered by the LRO. This training involves scientific visualization put together using LRO data to highlight the features that they will see from orbit. That means when Artemis 2 launches next year, which again does not plan to land on the moon, the 4 astronauts on board have been trained on how to identify lunar landmarks from lunar orbit. Preparation is key. And speaking of the moon, on to today's latest news from Chandrayaan-3. India's Pragyan lunar rover has found evidence of sulfur on the moon. The rover's payload instrument LIBS, which stands for the Laser-Induced Breakdown Spectroscopy, has made the first ever in situ measurements on the elemental composition of the lunar surface near the South Pole. According to ISRO, these measurements confirm the presence of sulfur in the region unambiguously, something that was not feasible by the instruments on board the orbiters. Early results from the experiments being carried out by ISRO's rover have unveiled the presence of aluminum, sulfur, calcium, iron, chromium, and titanium at the moon's south pole. Further measurements have revealed the presence of manganese, silicon, and oxygen. ISRO says a thorough investigation regarding the presence of hydrogen is underway. And India's space industry continues to ride the wave of success following the Chandrayaan-3 lunar landing, and the latest story comes from a Earth observation data and analytics firm called SAIC. They have raised $15 million in a Series A funding round, and this new funding follows earlier investment from the top private sector Indian banks in February of this year. With this new capital, SAIC plans to build a fleet of 4 high-resolution optical and multispectral satellites. This mission is expected to launch in the fourth quarter of 2025. The new financing will also be used by the company to accelerate product innovation and expand its operations across the Americas and Asia-Pacific regions. The UK's Civil Aviation Authority, also known as CAA, has confirmed that SaxaVord will not need a spaceport license to hold suborbital launches as long as the altitude stays below 50 kilometers. This opens the opportunity for the maiden flight of the high-impulse SR-75 rocket. SaxaVord Spaceport on the island of Unst in the north of Scotland submitted an application to the CAA for a spaceport license in March 2022. The CAA also says that the vehicle has to also be equipped with engines below a predetermined size, which the SR-75 meets. The high-impulse SR-75 rocket expects to reach an altitude of approximately 47 kilometers in its maiden flight, making it just a smidge below the top threshold. We look forward to seeing it lift off soon, and we'll be bringing you an interview with Saxavor's CEO in the coming weeks. Azerbaijan has adopted the Law on Space Activities into its national space legislature. The law regulates the legal, economic, and organizational basis of space activity in the country. The document covers national activities and entrepreneurial activities in the space industry and includes a thorough analysis of safety in space activities and the space industry. Now, Azerbaijan is looking to provide the legal basis for maintaining the registry of space objects at national and international levels. The space law will also provide the basis for certifying space systems, controlling the reliable management of space objects, managing the radio spectrum serving space activities, and guaranteeing the environmental protection and safety of space activity. There's a trailblazing anniversary that we should take note of now. 40 years ago today, on Tuesday, August 30th, 1983, Dr. Guion Bluford, also known as Guy Bluford, was the very first African-American astronaut to ever go to space. His first mission was aboard the Space Shuttle Challenger as a mission specialist for the STS-8 mission. A decorated Air Force officer and pilot, over the course of his astronaut career, Bluford spent 688 total hours in space, that's about 28 days, and went on 4 missions. And as we get to the end of our news read today, an answer to the trivia question from the top of the show. 39 years ago today, the Space Shuttle Discovery launched on its maiden voyage. Discovery was the 3rd shuttle to make it to space, and the STS-41D crew of 6 astronauts included Commander Henry W. Hartsfield Jr., pilot Michael L. Coates, mission specialists Mike Mullane, Stephen A. Hawley, and Judith Resnick, and payload specialist Charlie Walker. You can find links for further reading on all the stories that we've mentioned today in our show notes. And as always, we've included a few extra for some light reading for you. One's from Via Satellite on space agriculture, and another on the U.S. Space Force developing new tactics, and the last from the London Politica on an overview of global space governance. You can find all these stories and much more at space.n2k.com. Just look for this podcast. Hey T-Minus crew, if you find this podcast useful, please do us a favor and share a 5-star rating and a short review in your favorite podcast app. That will help other space professionals just like you to find the show and join the T-Minus crew. Thank you so much for your support. We really appreciate it.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
Our guest today is Charles Rath, and he's the founder and CEO of RS21. In this interview, Charles joins our executive producer, Brandon Karpf, to discuss the data service company's SPAICE, and that's SPAICE, resiliency tool, which has recently been accepted into the Department of Defense's Tradewind Solutions Marketplace. Brandon began by asking, where exactly do we stand with AI for space systems?
So RS21 is a data science and AI company. The part of AI that we tackle in space has to do with preventing failures. A shockingly high percentage of things we send into space fail for a variety of different reasons. And AI and machine learning can harvest massive amounts of historical data, but also real-time data that are coming off of satellites and other things that are in orbit. And we can use that information to predict with a pretty shockingly high accuracy rate when those things are going to fail, and also, and perhaps more importantly, how they're going to fail, which is a big breakthrough in AI and machine learning over the last couple of years.
When you say predicting failures, at what stage of the pipeline are you predicting failures?
Our platform will work during manufacturing with historical test data, but also, more importantly, in orbit. And we can predict failures up to 36 hours in advance. And, it's all about moving from what has traditionally been a reactive posture to a proactive posture, to be able to do the tweaking and the things from the ground that will prevent these things from turning into space junk.
Kind of curious, me, from my own naive perspective, I'd think, okay, we can predict 36 hours in advance an error or a failure on orbit. What can we then do about it? I imagine it depends what the error is, but can you give us maybe a sense of some, whether you have any case studies or ideas of, we identified this error and we're actually able to take action on the error?
Yeah, so, satellites are very much like a car in many cases. Things go wrong. Could be in the thermal power supply, could be in a communication system, could be something that is electrical. And like cars today, you can actually troubleshoot a lot of those things remotely. You don't have to send someone up in orbit to track the satellite down, but operators can do that from the ground.
What type of data do you ingest to get a high-fidelity signal on future maintenance needs or corrective actions that you can take for a satellite? What do those data feeds potentially look like? What's the type of information that you need to successfully predict future issues?
Yeah, so massive amount of data coming off of the various component parts of the satellite themselves. But in addition to that, also things like space, weather, orbits, other satellites that are in orbit. And so it's the internal data that's coming off of the satellite, the external data that we're looking at as well. And all of those things come into our platform and can provide those unique and sometimes small signals that an operator may not be able to see just by looking at it in a spreadsheet or from a human perspective, that our AI can pick up with a pretty high level of accuracy to prevent bad things from happening.
Identifying the signal and all of the noise.
Exactly. I mentioned to you before the podcast started, we didn't build this company to become a leading machine learning provider in space. In fact, our algorithm that this was modeled off of actually started in oncology research. And is actually predicting when cancer patients would fail, for lack of a better term. And so harvesting massive amounts of data on patient, the tumor type, medications they may have received. And so we were contacted, I guess, 4 years ago by the Air Force Research Laboratory to join a competition around helping them develop an algorithm to prevent satellite failures. And we have a lot of experience in healthcare, and so we use that cancer methodology and applied it successfully with some data that we got our hands on from NASA to make all this happen.
It's an incredible genesis and journey. Could you tell us a little more about, I guess, that competition that you mentioned, that they reached out to you to join, and how you went about essentially porting a capability from healthcare over to an engineering issue in the aerospace industry? That's a fascinating evolution of a technology. Can you walk us through that a little?
Got to give kudos to the Air Force Research Laboratory, a couple of gentlemen, one by the name of Matt Fetro, another by the name of Gabe Mounds, who they were the work that we were doing in data science and AI, and approached me and said, "Hey, Charles, look, I know that you guys typically don't work on defense and space-related applications, but we're doing this thing called the Hyperspace Challenge. And it is I believe it was an 8 to 12 week long program where we will give you an opportunity to engage with operators and experts in the field about the challenges that they're facing. And we'll give you an opportunity to come up with a novel approach to solving those problems." And so I went back to my team and I'm like, hey guys, boy, do I have an opportunity for you. We're going to win this competition in space. And they're like, you're crazy. But, the human mind is amazing when challenged. And we have this incredible data scientist named David Dooling. He's a quantum physicist. And he came back and said, hey, I think I have an idea that can solve this problem. And I just need to get my hands on some data. And he pitched to us this idea of survival analysis that he had actually created earlier in his career. And so we talked to the operators and asked them where we could find some open source data to test this idea. And they turned us on to this NASA data set, and we tested it, and it was highly effective. And we won the competition. I mean, we beat out organizations like Johns Hopkins and organizations that had been funded exponentially higher than we have. And here we are, this little small company in Albuquerque. And it was a pretty big deal.
Did anyone on the team have any heritage or background from the space industry, or was this totally new for the team?
I'm totally new. And what AFRL does and Hyperspace Challenge does that is absolutely brilliant is they connect you with that domain expertise. So we had access to those types of people that were working alongside our data scientists and our software developers and our engineers to come up with a solution. Now, since then, after winning the competition and then, receiving a fair amount of funding and a lot of support, we've brought on that talent in-house. But in the beginning, no, it was a bunch of do-gooders and data scientists and AI practitioners that thought we'd throw our hat in the ring.
So I think that experience is particularly relevant for a number of folks in our audience, right? What lessons learned did you really derive from that experience being with a group who were not aerospace professionals, but diving in, solving some legitimate problems in the aerospace industry, and then ultimately what you have now is getting to market with a viable product, a viable business model that really does solve some legitimate challenges that folks in the industry have. What lessons learned did you take from the Hyperspace Challenge?
First and foremost, the space industry is growing at an exponential pace. There's massive opportunities for entrepreneurs to make a difference, whether it be in satellites or all the other elements that exist in the space economy, and the race to space from a military perspective as well. And so it's a good place to go to be entrepreneurial. For us, it's the nexus between space and AI that is particularly interesting. And, the way we looked at it is, look, data is data. Failures are failures. We can be looking at cancer patients or we can be looking at satellites. These things are comparable. And at the end of the day, it's just data. And so, I think to have that entrepreneurial ethos and to think about how what you may be doing could be applied in a different problem area, particularly one that is so thirsty for innovation, I would encourage you to look into it.
So then thinking for yourself and your company, what comes next, right? Just in the last few weeks, we've seen reports out of China, right? China launched a AI-brained satellite, whatever that means. What comes next for AI, data analytics, data science in this industry? What are you looking towards in the next few years?
So for us, again, just kind of going with the consistent theme, we want to expand in satellites. We want to be the provider of preventative maintenance and prescriptive maintenance as it relates to this problem of space junk and satellites failing. And then, just like when we went from cancer patients to satellites, we can go from satellites to helicopters to aircraft to Navy ships to data centers to really anything that is spitting off data. And so, I think that's why this is such a success story for AFRL and RS21 is that not only did they allow us to tackle a very big problem in a very niche market, but then we can expand it into other markets as well.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. Now, I just love this next story. From the archives of the National Endowment for Humanities comes a tale of how Pan American Airlines started selling tickets to the moon. Yes, the same legendary Pan Am, known as the international air carrier and unofficial overseas flag carrier of the United States for much of the 20th century. It seems that the airline saw a marketing opportunity at the height of the Cold War space race after a journalist asked a travel agency in Vienna for a ticket to Earth's nearest natural satellite. The airline then launched its first moon flights club in 1968, inviting customers to book spots on their future lunar routes. Their projected start date was the year 2000, of course. Participants even received a membership card with the member's name and official number on the front. The airline says they processed around 93,000 memberships between 1968 and 1971, and I should add that these memberships were free of charge. They stopped taking reservations in this program due to the sheer administrative and financial strain of it. Now, if you are one of the lucky folks who actually signed up for this at the time, I would love to hear about this. Share with us your thought on this crazy but fun marketing stunt. You can email us about your experience at space@n2k.com. That's it for T- for August 30th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. And we'd love to know what you think of our podcast. You can always email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. This episode was produced by Alice Carruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karp. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazis. Thanks for listening. We'll see you tomorrow.